Our final new concept in Chapter 8 is going to be graphing linear inequalities. We have done this before on number lines, graphing inequalities, but now graphing linear inequalities, we'll be putting them on a coordinate grid. So a linear inequality is two variables and is the result of replacing the equal sign with an inequality symbol. Because inequalities can have a set of many solutions, a method of shading is going to be used. So example 1 is something we're used to with equations, checking the solutions. So it says tell whether the ordered pair is a solution of 2x minus 3y is less than 6. I don't see anything in the question about graphing, so I don't need to worry about changing the form of that equation or inequality. So all I need to do is the same as I have been, substitute for x and y to see if it's a true statement. So 0, 1 is the first point we're going to check. And I'm going to put that into the original equation. I'm going to replace the x with 0 and replace the y with 1. And when I multiply that out, 2 times 0 is going to cancel out. We have a negative now. Is negative 3 less than 6? Yes, it is. So the 0, 1 would be a line, or would be a point on the solution. Now, if I go ahead and test point 2, negative 4, again, I'm going to just substitute that in for x and y. 2 times 4, which is x, minus 3 times negative 2. And we want to see if that's going to be less than 6. Again, going back to the original equation. 2 times 4 is 8. Negative 3 times negative 2, watch your integers, is a positive 6. 8 plus 6 is not less than 6. 8 plus 6 is 14. So 4, negative 2 would not be one of the solutions for this linear inequality. Now we come to the graphs. So the graphs of a linear inequality in two variables is the set of points in a coordinate plane that represents all the inequality's solutions. So if I was going to graph 2x minus 3y is less than 6, which was our equation or inequality from the first slide, I do need to put it in slope-intercept form to be able to graph it. So I'm going to get rid of my x's. And then I would end up with my 3y and negative 2x plus 6. The next thing I need to do is divide by negative 3. And if we remember our rules, when we divide by a negative, when we're in inequalities, we need to flip our sign. So our sign is going to go the opposite direction. So now negative 3 over negative 3 gives me y. The sign is flipped because I divided by a negative. Negative 2 divided by negative 3, negative divided by negative gives me a positive, so I have 2/3 x. And a positive 6 divided by a negative 3 gives me negative 2. So here's my new equation that I have the information to graph from. So first I'm going to do the y-intercept, which is at a negative 2. And then I'm going to use my slope here, up 2 over 3 from our 2/3. So up 2 over 3, and I have my coordinate points to draw my line. I need 2 points to be able to draw a line. Now, something that is new in this equation is that we do not have equal. So the points that lie right on the line will not be solutions. Because my inequality symbol is simply a less than or a greater than, in this case it's a greater than, I'm going to use a dashed line. The dashed line represents that this is where the equation would be on the graph. However, the points that are lying right on this line, the dashed line, are not included in the solution. So if we go back to our solutions that we had here, 0, 1, 0, 1 would be right here. So I'll go ahead and put a point there. And we said that one was a solution. The other point that we tested was 4, negative 2. So if I go to 4 over 4 and down 2, this is not part of the equation. There's one last step for inequalities, and that is the shading. To shade this equation, we would go ahead and we would test a point. Now we had 2 points already tested from the example 1. However, normally the best way to test a point is to check and see if 0, 0 will work in that equation. So I can test this either in the original equation, or I could test it in our line. Now 0, 0 is nice because when I do 2/3 times 0, it knocks that term out. So now I just have -2 on this side. If I replace y with 0 as well, because I'm testing the point 0, 0, I can now say, is 0 greater than a -2? 0 is greater than a -2, so the point 0, 0 will be in the solution set. Now that would mean that I'm going to shade in the part of the graph 0, 0, which is above this dashed line. Any point that appears in the shaded area would be a solution. The points right here on the line will not be a solution. And as you can see, when we checked before, 4, -2 is not in the shaded area, so it is not a solution. So the new things to remember when you are graphing an inequality, you will use either a dashed line or a solid line. And then when you get done, you need to do a test point. 0, 0 is the easiest one. And when you put that test point in, if 0, 0 works, you're going to shade on the side of the line that 0, 0 is in. If 0, 0 does not make it a true statement, you're going to shade the section or the part of the plane that is not included with 0, 0. This is known as the boundary line, would be your dashed or solid line, and the shading is creating two half planes. So if we go ahead and do this graph instead, this time the inequality symbol is a greater than or equal to. Now they've already put this in slope-intercept form for us, making it a little easier. We'll go ahead and we'll do our y-intercept of a +4, and then we will use our slope. Maybe it's being very touchy, my clone there. Goodness. And we're going to go up 2 and over 1 for our slope. Now this has an equal sign in it, so we will graph this the same way we were graphing linear equations before. The equal sign again means that the points that fall right on the solid line would also be solutions to this set. So we've done our boundary line. We have our points like we always have had. We have our boundary line. Last step, we need to figure out which side of the line we are going to shade. Again, let's put 0, 0 in here. So 2 times 0, making x 0, would be 0. We would still have our +4. And if we replace y with 0, we have, is 0 greater than or equal to a +4? It is not greater than or equal to. So the point right here at 0, 0 is not included in the solution set. So if I shaded on this side of the boundary line, I would hit 0, 0. So instead, I need to shade on this side of the boundary line. Your shading, I'm sure, will be much nicer than mine is right now. Now remember, because it's a solid line, any of the points that appear right here on the line would also be a solution. This one here, I don't know if you can still see it, is 8. So this point is 2, 8. I could check that. 2, and my x is 2, so 2 times 2 is 4, plus 4 is equal to 8. So this is also part of the solution set. When you're shading a solid line, you can get real close to that line because it includes all of those coordinate points. Now we have special lines. We have lines that do not have any slope and only have one variable. X is less than 3. Now we talked about these when we were talking about equations. If I only have an x, I'm going to go ahead and I'm going to put my point, again it's being a little touchy there, at 3. Now no matter what y is, x is going to be 3. didn't get that one. I'm going to pause for just a second. Okay, since we have x is less than 3, x will always be 3. I'm looking at my symbol. My symbol is less than, not including a equal sign, equal to. So I'm going to have a vertical line. Now we spoke about this at the beginning of chapter 8, or in chapter 8. And now, again, I'm going to use the same method I have. I have my boundary line, and I need to know how to shade. So I'm going to replace and check 0, 0. Well, this time I only have one variable, so x0 is 0 less than 3. It is. So, again, I would be shading to include the 0. Again, this would mean any of the points over here would work, but we will not include right on the line there because it's a dashed line. Looking at another one with only one variable, this time I have x is greater than or equal to -2. So I'm going to go ahead and I'm going to find my -2, if my clone will work there. So here's y is -2. Y is always going to be -2. I look for my boundary line and I have an equal to in there as well, greater than or equal to. So this time, as we learned in the beginning of chapter 8, or the first part, I'm going to have a horizontal line. Now, same procedure. I have my boundary line. Let's see which side that I'm going to shade on. So if I replace this with 0, is 0 greater than or equal to -2? It is. So I need to shade the portion of the graph that would include the 0, 0 mark. I would shade upwards. And this time, because it's a solid line, any of the points on there would also equal, or would also be a solution to this equation. Now we'll finish this up with a word problem. And you have 100 pounds of clay to use for making bowls and vases. You need 5 pounds of clay for each bowl and 2 pounds for each vase. Write an inequality describing the possible number of bowls and vases that you can make. So I went ahead and I'm going to say 5 times x, because that's going to be my 5 pounds of clay for each bowl. And then I'm also going to do 2 times y, because that's for my vases. When I did this, I said it was less than or equal to 100. Now, because this is a graph instead of a coordinate grid, I'm going to go ahead, I'm going to put 0 in. When x is 0, so 5 times 0, that would get rid of this part of the equation. So 2y is going to be less than or equal to 100. 2 times what would equal 100? 2 times 50. So when x is 0, I'm not moving left or right here. I'm going to go this way. Y is 50. And here's my point. Now, this time I'm going to replace y with 0. I'm only going to have an x. 5 times what is less than or equal to 100? 5 times 20. So my x coordinate point would be at 20. Now it says that it's less than or equal to 100. Again, if I would replace both of these with 0, 0 plus 0 is definitely less than or equal to 100. So I want this to be in my equation, and you could think about that just as the beginning point anyways. And then we would shade inside here. And those would be all the solutions that would work for how many different possible combinations of bowls and vases we can make. So we could go right on a coordinate point here, and we could say we're going to do 10 bowls, because that was my x, and then it's going to give me 10 vases. So, or I could make, again, if I made 20, I could only make, if I made 20 bowls, I couldn't make any vases. And if I made 50 vases, I couldn't make any bowls. I could go to another, and I would just go to ones that match exactly. So if you see this one, if I was at 30, this one I can't quite tell with the way I have the graph. I'd say maybe that's at 12. And I could go ahead and put those points into x and y and see if they are a true statement. And that way I can figure out several other combinations. So the easy ones to find would be I could make five vases or 5 bowls, and if I made 5 bowls, I could make 20 vases. I could always go up and have even more than that. I could make 10 and 10, and I could also make 20 and 0. All right, that concludes the last lesson of Chapter 8, 8.9.